In previous experiment, I explained how to do null offset adjustment. Here you are seeing a 0 0 output voltage. If you move here, you are getting positive, on the opposite side negative. So somewhere in between you are getting 0 volt at 20 volt range. This is DC volt. Okay, so now after completing this null offset, let's start for inverting amplifier. In inverting amplifier, we are connecting input to pin number 2, that is the inverting terminal, and pin number 3 is grounded. So the other part of the circuit remains same. Here you are seeing from output this 10 kilo resistor is connected. The other end of the 10 kilo resistor is connected to pin number 2. Then this pin number 3 is grounded, and these are the 3 power supply. I'm going to disconnect it and again start. So I'm starting from the beginning. Let's connect first positive supply. The positive of this supply is connected to plus 15 volt. Then this negative of the dual power supply is connected to this minus 15 volt. Then this ground using green wire connected to this ground terminal of the trainer. Here we can take 3 gain. First gain is 10, then 5, then 2. For gain 2, we will use this. For 5, this, and for 10 is feedback resistor upon input resistor is the gain. So for gain 10, this potentiometer value should be 1 kilo. So here you are seeing, you can see here it is 1 kilo. This will keep 2 kilo. Let's increase this to 20 kilo. So now you can see it is 2.04. Since it is exceeding about 2, that was on 2 kilo, it may exceed this range. So that is why I changed it to 20 kilo and now adjusted to 2 kilo. Then this will keep it on 5 kilo. So this you can see 5 kilo, this is 2 kilo, and this one 1 kilo. If there is error or if the reading is less or more, then accordingly there will be error at the output side. Now since hereafter we want to use this as a digital multimeter to use voltmeter, so let's change this to 20 volt, and this connecting to output terminal and ground. Now let us connect feedback register from output to this 10 kilo resistor. Then the other end of the 10 kilo resistor is connected directly to the pin number 2. The input of this regulated power supply we are going to connect to this input and the other end to ground. So this input is given here, dual power supply, positive, negative and ground are connected to this positive, negative and ground respectively. This digital multimeter selected at 20 volt range, of course DC volt, is connected to this output terminal. Now let's switch on this power supply. Let us switch on this also. You can see this LED is glowing. This LED here there are two adjustment, fine adjustment and this coarse adjustment. This cause adjustment we have not selected. Since we want voltage like zero point 0.5, 0.8, 1, therefore by using this fine adjustment, let's first make it zero point 0.5 voltage. So since input voltage is given 5 voltage and the gain of this operational amplifier is 10. Why 10? This is 10 kilo and this is 1 kilo. So 10 divided by 1 is 10. Therefore output should be equal to 5 volt. Here pin number 3 is not grounded, so you have to ground this non-inverting terminal. So here we are giving input to inverting terminal. So if here it is 0 0.5 volt, then output should be equal to -5. Minus symbol indicates that it is inverting. So here you have seen that output is 10 times input. Let's take other reading. I have kept this meter adjacent to this power supply. So you are seeing that for 0 0.5 volt input, this is 0 0.5 volt input, this input, and this meter is output. You are getting 10 times output voltage. Now let's vary this fine adjustment. For 0.63 you are getting 6.4, 0.7 you are getting 7.4, 0.85 you are getting 8.5, 0.93 you are getting 9.5. For one input expected output is 10. See here you are getting 10. This small error may be due to the tolerance, since here plus minus 5% variation is possible because of gold ring. So this small error is expected. Then for 1.2, this 1.16 you are getting 11 point. For 1.3 you are getting 13. See now this 14.25 is the maximum voltage. Beyond that it is not increasing. So find out the voltage given at the input when the output enters into saturation. Note down again that 14.2 or 3 is the maximum. So see here 1.4 voltage is the highest input voltage given. Thereafter it is not exceeding. So here this 1.4 is a saturated reading. Now let's change the gain and repeat the same procedure. Here so far what you have done, we kept gain 10 constant, we vary the input and have seen the output. You have to take 4 reading, you can take any 3 reading. For example, for this zero point 0.4 volt you are getting minus 4.9, this is one reading. Then for zero point 0.2 minus 2.16, this is second reading. This is third reading. For 1 you are getting 10 times, means 10.25, and the last reading is saturation reading. In this way you have to take minimum 4 readings. Then we will change the gain. For that, this input register which we kept at 1 kilo should be changed. So for 1 10 volt. Now let's insert into the upper where it is selected or kept at 2 kilo. So 10 divided by 2 is equal to gain 5. So output should be 5 times input. If input is 1, output you see it is 5 volt. For zero point 0.5 you are getting 2.5. For 2, 5 to the 10, you are getting 2. For 3, it is not possible to get 3 because 5 3s are 15. 15 is above this applied voltage, so you have to reduce it. For 2.4, for 2.4 expected is 12.5. See here, you are getting this 12.6. For 2.5, now I am wearing this course adjustment. Expected is 12.5. Here you are getting 12.4. Then after wearing this, here it enters into saturation. This is the saturation value. About that, there will not be any variation in this output voltage. See, this is increased 3 4, but here it remains 13.3 constant. So this is the saturated reading. Please note that it is not necessary that both this voltage and this voltage will show the exactly same value. So if you are getting different values, then please check that this voltage, suppose it is here, it is showing 3.39, then directly connect this to this digital multimeter. If it is showing here also 3.39, means this input voltage whatever we are getting is right. If different, then instead of taking this reading, take this reading. You have to connect this digital multimeter at the input side as well as output side. Here at present, here it is connected to output, but if this output and this output are not same, then you have to connect this digital multimeter in to input side as well as output side. Now let's take the last gain. So in last part of this experiment, let's change to the uppermost. Here value of the resistor is 5 kilo, therefore 10 divided by 5 is equal to 2. So gain is minus 2 here. Here input is 2.5, you can see 2.5. So output is minus 5. Here it is 2.5 and output is minus 5. For 3 it should be 6. For 3 you are seeing here it is 6.1. For 5 it should be 10. Here you are seeing 10 for 5 voltage. It is 10. So maximum will be 6 point. So this is the highest possible input voltage. After that output remains constant because it enters into saturation. So this is all about this inverting operational amplifier experiment. Here we have given only DC input, that is why we are getting DC output. If function generator is connected at the input, then you have to connect CRO at the output side, where you will see inverted output. If I change this polarity, then you will see the positive sign. See, now here it is positive. So for 6 volt, 6 2s are 12, you should get 12 volt at the output. This is 5.99, so here it is 11.96, means 12 voltage. So here it is positive, and this is the previous condition where you got this negative. Hence, it is acting as an inverting amplifier. Once again, let us trace this circuit. Positive is given to this terminal plus 15, negative is given to this minus 15. This is ground. Then this is connected to feedback resistor 10 kilo. If out of these three any two are faulty, suppose this is working, then after taking first gain reading you can change this potentiometer value, then take the second gain reading, then again change this, you will get third gain reading. But since all these three are working, therefore simultaneous, not simultaneous, one after the other, but without changing potentiometer each time, you can get readings for different gain. This part we have not used it. This is used only in Smith trigger and comparator. Only here we have used this part. This part will be used in subtractor. For adder, all these three inputs will be required. So that's all about this inverting. Let's meet in next experiment. Goodbye.